Okay, we're going to start looking at another optimization problem with a little bit of additional issues around it. And so the question is, find the minimum total surface area. So we know that minimum total surface area is going to give us, basically that's what we're going to be using as a formula. And luckily enough, they give us the formula here for the surface area of a cylinder, but they also give us the volume. And there's a reason for that. And this happens a lot in optimization questions because often in your formula, you have more than one unknown. And in this case, we have basically an H and an R that's unknown. And we can't have two unknowns in our formula if we're going to solve it. So this formula, the volume formula, helps us sort that out. And they give us some information about the volume. They tell us the volume is equal to 1 cubic meter. So volume is 1 cubic meter. And so what we can do is we can write down the volume formula, pi r squared h is equal to 1. And then we can do this formula in terms of either h or r so that we don't have both of these. But I'm going to do it in terms of h is equal to 1 over pi r squared. So that's the first step to doing this. You're going to have to, and often you have to do this, you have to put one of the formulas in terms of one of the letters. So that I can substitute it in to the surface area and only have to deal with one letter, R or H or whatever it happens to be. So now we have the surface area formula, which is 2 pi r, and instead of h, I'm going to put in 1 over pi r squared plus 2 pi r squared. Now, I'm going to simplify this before I start doing anything with it, and I'm going to end up getting 2 r's on the bottom, so 2 over r plus 2 pi r squared. That's the surface area formula. Now I want to find the minimum surface area. So obviously I'm going to have to differentiate, and I'm going to have to make that differentiated expression equal to 0. So if I'm going to differentiate this, what I might want to do before I might want to bring this r back up so it makes it a little easier to differentiate. So I'm going to do an extra step, which is to bring this r back up and make it r negative 1 with our rules of exponents plus 2 pi r squared. Now I'm going to differentiate. So when I differentiate this, I get negative 2 r to the negative 2 plus 4 pi r. Now make that equal 0. Now at this point, you can throw this into your calculator, put the r's as x's, and solve this thing, or you can do it by hand if you want. So I'm going to do this by hand. I'm going to move that over there by adding it to both sides. So I'm going to get 2 positive 2r to the negative 2 is equal to 4 pi r. I'm going to put that back down on the bottom. I know this is, oops, it's kind of problematic, but I'm going to put so that I can deal with this a little bit easier. Then I'm going to multiply everything by r squared, and I'm going to get 2 equal to 4 pi r3. I'm then going to divide by 4 pi, and I'm going to take the cube root. Cube root of 2 over 4 pi. So that's going to give me r. Now once I find r, I can simply stick that back into my formula that I have written in terms of, so it's this formula here, where I only have r. And the thing is that with this, we've got basically the surface area is a quadratic, so we know that we have a parabola. We know that with a positive parabola, we have only a minimum point. So if you were to do this positive parabola, so that when you say that you find your minimum point, you basically, your R is your minimum point. That's enough justification. So when I find R, when I do the cube root of this, it's going to be a minimum point. I know it's a minimum point because I'm dealing with a positive cubic. So I don't need to do a whole lot of nature of the roots and things like that. Once I get this value, then I can simply plug it in to my original formula, this one here, with just the R's in it, and solve. And then I get the minimum value. And I don't have the answer key here, but if I go up to the test and I look at the answer key, just cheating a little bit, I'm not going to calculate this, but I can do it this way. You can do this. Why am I doing this? You can do this. So R ends up being 0.54, and then the final answer, 5.54.